Hello everyone. In the previous class, we have discussed about the collections framework, why it is important. Basically, it provides us the capability for efficient storage and efficient manipulation of the collection of data items. Now, we have already seen that if you want to add a new item to already existing collections, if you want to manipulate a data item, if you want to delete something, if you want to remove, if you want to insert anything new in an existing set of collections, it was cumbersome. So for our help, the collections framework has been provided that allows us for efficient storage and efficient manipulation of a collection of objects. Now, we will see in this class one of the concrete classes, that is ArrayList. We can compare ArrayList with the arrays. Normally, as we have also seen in the previous class, an example where we have 15 elements already in an array. Now we want to add a 16th element. In the earlier cases, we would have to create a new array with the size 16 and then add it. If you want to delete now any of the element from that array of 15 elements, we would have to delete an element and copy the rest of the elements back to it. And if the size is longer, that is really very cumbersome. And so on and so forth. There are lots of problems that we may face it. Now, for our help, ArrayList has been provided. What does ArrayList do? ArrayList provides a set of cleaner methods that allow us to add and delete without worrying primarily about what will happen in the backend when we are extending the size of the list, or we are deleting, or we are changing, or so on and so forth. So those things are taken care automatically in the backend by the class ArrayList. So now if we use the object of the class ArrayList and then we use an ArrayList, the things will become simpler as compared to when we are using array. Let's take an example. So in this array list, we have taken a new array list whose name is A1 or AL1, array list 1. Now in this array list, we're using the method add to insert some new element in the array list, and we have created another array list in which we're also adding two different elements. In the first one, the elements are of integer type, and the second one also are of integer type. Now, for now, we just want to make sure that in the new array list that is provided, A2, all the elements are added to the array list 1. So we can also add one by one the elements, or we can add all the elements of an existing array list to the other array list. So for that matter, we have add all method that provides us these capabilities. Whatever are the elements of a array list 2, they're all added to array list 1. And the addition happens at the end. So they are appending at the end. Now you may worry about in the existing knowledge of us, if we had an array, we could have size 2, we could have size 3. But as soon as we keep on increasing, we would have to resize the array based upon we have to copy it and we have to manipulate it. Now this on the backend array list keeps track of when we are adding and when we are the size of the array list increases. We can also sort that as well using the method sort, and we can definitely print the entire array list AL1. So when we are printing the entire array list, you may see that they are printed in a sorted order. We can also get the exact element at the particular index. So index starts with 0, so 0, 1, 2, 3. At the third index, we have 53 because the array list has been sorted as well. So this was a simple example of ArrayList, how it can work. We can add it, we can sort it, we can get a particular index, get a particular element at a particular index, and so on and so forth. Now there is a so in the next class we will see about the list iterators.